right, day 2 is going to be a little bit more vocabulary and some recap, and then we'll move on from there to work on some distance formula, I believe. So a postulate is something assumed to be true for the basis of reasoning. An axiom is the same exact thing. We won't really ever use the word axiom. A theorem is something that must be proven to be true. We'll deal with a lot of theorems starting in Unit 2. A coordinate is each group of numbers used to indicate the position of a point, line, or plane. Distance, the shortest distance between two given points, and midpoint, the point that divides a distance into two congruent segments. These last three should all ring a bell from algebra. I know it's been a while, but we'll go over all of those here in just a minute. So remember your labeling. AB with a double arrow over the top means that it is a line that extends without end. AB with one arrow means that we have a ray AB, the endpoint being A, and extends in the direction of B without end. Segment AB will have this bar above it with no arrow. If we take the bar away, as it is here, we're now looking for a length. So AB without the bar over the top will be referring to a numerical distance. If we have two bars over the letters, these mean that our line segments are congruent. And if we take away the bars, we also take away the squiggle mark. And we would say that the length of AB is equal to the length of DC. So I'm going to actually redraw this piece here for our markings for congruence. We're not going to be able to mark lines congruent, but we can mark line segments as congruent. So if I have A, B, C, D, and X, if I mark things like this, those little tick marks tell us that AX is congruent to XC. And if I mark these two with two little tick marks, that tells me that DX is congruent to XB, but that the ones with one mark and the ones with two marks are not congruent to each other necessarily. Here we have how to mark angles congruent, and here are our statements. All right, our ruler postulate just tells us that the distance between 2 points on a number line is the absolute value of the difference of the coordinates of the numbers. Remember that distance is always positive, which is why we take that absolute value of our numbers. I'm just going to skip down here. It says if A is at -10 and B is at 15, so I'm going to go ahead and get that written down. Here is A at -10 and B at 15. What number is 3/5 of the way from A to B? Well, the first thing that we want to do is look at the distance of the entire piece. So how far is it from -10 all the way to 15? And the answer to that is 25. And we're going to cut that into fifths. So if I do 25 divided by 5, that means I have 5 equal sections with all a value of 5. So I'm going to see if I can mark this out. 1, 2, 3, 4. Close enough. Each of these is going to have a value of 5. And if you want to, you can go ahead and just number your number line. So this would be -5 and 0 and 5 and 10. And this is saying is what is 3/5 of the way from A to B? So if I start back here at A and go 3 of those sections, 1, 2, 3, I am at the number 5. And if I change my color here and I want 3/5 from B to A, we're going to work backwards. So if I start here and work backwards, 1, 2, 3, that puts me at 0. So assume point C is between A and B on segment AB. Be careful with the word between. I don't like to draw C perfectly in the middle. And even if I'm wrong on where I draw it, at least my brain doesn't think that it's perfectly in the middle. So if AB has a length of 50 and CB is equal to 15, then all I've got to do is subtract 15 from 50, which would give me 35 for the length of AC. Notice that these do not have bars above them because we are representing actual lengths that have value. So I'm going to go ahead and erase these out and work the next problem. AC has a value of 2A plus 3. CB has a value of 3A minus 1. And AB has a length of 37. So what I know is that if I add those two at the top, they should equal the one at the bottom. So 2A plus 3A gives me 5A. A positive 3 and a negative 1 gives me a positive 2. And all of that should equal the total of the length 37. So 5A subtract the 2 would be 35. And A would have a value of 7. And just like any other algebra problem, we can plug things in and check it. So if I put a 7 into segment AC, that will give me 2 times 7, which is 14 plus 3. And if I plug it into CB, I'm going to have 21 minus 1, which is 20. And the two of those add together to give me that length of 37. This example is just another one of addition and subtraction, so I'm going to leave that alone. If you want to come back to it later, you're welcome to. I'm not going to focus too much on these. Remember that just like a clock, quadrant 1 is up top, but then after that, I like to write letters in there. So first thing, this is a graph. So if we follow the G around counterclockwise, here's 2, 3, and 4. We could also say that these are quadrants. Follow it around counterclockwise. And you could use grid. These are coordinates on a coordinate plane. You get the idea. If something is on an axis, it is not necessarily in a quadrant, so just put x-axis or y-axis. All right, distance and midpoint formula. Don't forget these from algebra. One thing that I will let you do as far as pre-AP is concerned is I want you to recognize that as far as the distance formula is concerned, these little tiny subscripts here don't really matter. As long as you do x minus x and y minus y, whenever you square them, you're taking the absolute value of them anyway. So use that to your advantage. You can go ahead and use and always do x2 minus x1, y2 minus y1, but in the distance formula, you don't have to. Keep in mind that on this first test, you'll probably have access to the formulas, and then after Unit 1, I'm not sure that you're going to be given those, so make sure that you learn how to use distance and midpoint formulas. The midpoint formula is the average of the x's, comma, average of the y's. So here on number 1, if I want to find the distance between Parker and Elm, I'm going to write in our coordinates first. So Parker is at 4, 1. And Elm is at 0, 4. And we want to find the distance between the two. So I'm going to go ahead and set this part up. And I'm going to do x minus x. I'm going to leave it as 4 minus 0 squared plus 4 minus 1. Instead of doing 1 minus 4, either way you're going to end up with a 3. So whether it's 3 or negative 3, whenever you square it, it's going to come out as a positive 9. So 4 squared is 16. And then if we do 3 squared is 9. So this is going to be the square root of 25, which then has a value of 5 units. find the distance between Maple and Parker. So I've got Parker again at 4, 1, and Maple is back here at -3, -5. So since we're subtracting these, I'm going to do the addition instead. And instead of doing -3 minus 4, I'm going to do 4 minus -3, which would give me a +7. So I'm going to do 4 minus -3 squared plus 1 minus -5 squared. So this gives me 7 squared, which is 49, plus 6 squared, which is 36. And if I add those two together, this will give me the square root of 85. And what I don't want you to do is to plug that into the calculator. What I do want you to do is to see if it can simplify. So this is one of those things that you learn at the end of algebra, and we recap it every year. We're going to start out with 85, and we're going to create our factor tree. 85 is 5 times, I believe it's 15 or 17. I can't think right now. Okay, 17. Yeah, 75 gives you the 15. 17 is prime, 5 is prime, nobody goes anywhere, so this will stay as the square root of 85. And I'm going to go ahead and put a little u after it for units. So now we're going to find the midpoint of these things. Remember, it's the average of the x's, comma, average of the y's. So if I want the midpoint of MP, that's from Maple, which is, let's see, -3, -5, and Parker at 4, 1. So if I average numbers together, I'm going to add them. And in this case, again, it doesn't really matter what order you add them in, because addition is what we call commutative, meaning that no matter what order you add the numbers in, you always end up with the same answer. So I'm going to do -3 plus 4 over 2, comma, -5 plus 1 over 2. And then when I simplify those down, -3 plus 4 is a +1, so I'm going to leave it as 1/2. And a -5 plus 1 is going to be a -4 over 2, which would give me a -2. All right, there's another midpoint question there, and I'm going to move on down. So if we are given A, B, C, and D, determine whether AB is greater than, less than, or equal to CD. So I want to look at this piece here, and then I want to compare these two. So let's do our math. I'm actually going to do that in a different color here in just a minute. I want the distance, and let's do A to B. So I'm going to have the square root of 2 minus a -2 squared plus a -1 minus 2 squared. 2 plus 2 is 4. 4 squared is 16. This will be a -3 squared, which is 9. So this will be the square root of 25, which is 5 for the length of AB. And then if we want to look at the length of CD, we're going to do the same thing. Let's see. For my x's, I have 4 minus 1 squared plus 5 minus 1 squared. I just flipped those around so I could use positives instead of negatives. I'm going to have the square root of 3 squared plus the square root of 4 squared, 9 and 16. So this is the square root of 25, which also gives me 5 for CD. So my overall answer is that AB is equal to CD. All right, given Z and A, we want to, A is the midpoint of ZP. So let's graph these out. Z is at -2, 4. 1, 2, 3, 4. And our P is at, that's the one we're going to find. So Z again is at -2, 4. A is at -7, 6. Okay. And our endpoint is going to be somewhere back in this direction. Now, what I want you guys to look at is almost like a stair step, okay? So if I know the midpoint, I can go back and up, and then all I have to do is go back and up again to find this piece. So if I just look at -2 to -7, what I have done is I have subtracted 5 for the x's. So I'm going to do that again. If I subtract 5 for the x's again, -7 minus 5 gives me a -12. And now let's look at the y's. So if I go from a +4 to a +6, I added 2 to the y's. So I'm going to do that again. And that is really the easiest way to do it, is just to think of it as a stair step. What did I do to get from one end to the middle? Okay, do that again from the middle to get to the other end point. Point K is the midpoint of JL. Find the length of KL. So if these two are congruent, which they are because K is the midpoint, then what that tells me is that I can set them equal to one another. So 8 minus 3x is going to be equal to 2x plus 5. And now we just go around and solve for x. So I'm going to add 3x plus 3x. So I have 8 is equal to 5x plus 5. And if I subtract the 5, let's see, I end up with 3 is equal to 5x and divide by 5. So x is equal to 3/5. And then to solve for that, we would just plug it back in and add them together. All right, last one for today. The endpoints of LM are at L, -4, 1. M is at 5, -5. So here is our line segment. What are the coordinates of the point that is 2/3 of the way from L to M? And how about the reverse? So think about what we did back at that problem at the very beginning where we had to go 3/5 in one direction. We're going to do the same thing, except now we have to do it twice, once for the x's and once for the y's. So let's focus on the x's first. X's move side to side. So if I want to go from L all the way over to M, from left to right, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 total units. And if I want to go 2/3 of the way, well, 1/3 of 9 is 3, so 2/3 of 9 is 6. So what I'm going to do is I'm going to move 6 spaces in the direction from L to M. 1, 2, 3, 4, 5, 6. Right here. Now, let's look at it from the perspective of the y's. So if I want to go from L to M, here's L and M down here. Again, we're going to split it into thirds. So this is 1, 2, 3, 4, 5, 6 total spaces. And if I go 2/3 of that, a third of 6 is 2. So 2/3 is 4. 1, 2, 3, 4. And now we're going to look at where those meet. Here and here. So 2/3 of the way from L to M would be at the point 2, -3. And then if I wanted to reverse that, I'm going to just count backwards the other way. It's still going to be 6. 1, 2, 3, 4, 5, 6. And then if I want to look from M to L, let's see, I can go 1, 2, 3, 4, and find where those two cross as well. And those two would cross at -1, -1. This will take some practice. M to L will be -1, -1. On your quiz or in a test, if I ask you to do this, there will be a graph there. I would discourage you from trying to use a formula. You can, but things just kind of get a little crazy. So drawing it out and taking that stair-step approach will be very helpful.